Hello, everyone, and welcome. My name is Cara Patton, and I am the Technical Assistant for the Environmental Restoration Program area of SERDP and ESTCP, and I will be introducing today's webinar. Today's webinar will focus on the updated Suite 2 spreadsheet software developed under an ESTCP project led by Dr. Jovan Popovic from the Naval Facilities Engineering and Expeditionary Warfare Center. Dr. Popovic is joined by his project team members, Mr. Christian Johnson and Dr. Katie Muller from Pacific Northwest National Laboratory, and Mr. David Becker from the U.S. Army Corps of Engineers. After the presentation and software demonstration, we will conclude the webinar with a Q&A session. Next slide, please. The next several slides provide instructions on optimizing your webinar experience. If you've not done so already, download Zoom at the link shown here and provided to you in your webinar registration confirmation email. If you cannot download Zoom, you may view the slides using a compatible internet browser such as Firefox, Internet Explorer, or Edge, and by creating a free Zoom account. If you are unable to view the slides and your screen freezes, try keying Control and F5 together to perform a hard refresh. Next slide. If you are accessing the audio through your computer, click the arrow next to the Join Audio button. Select Test Speaker and Microphone and follow the prompts as they appear on your screen. If you continue to experience difficulties, please call into the conference line shown here on this slide. You may also submit a comment using the chat box. Please use the chat box only for comments related to technical difficulties. The Q&A option should be reserved for questions for the speakers. Next slide. In case of continued technical difficulties, you can download a PDF of the slides from the webinar webpage and call into the conference line provided to you in your webinar registration confirmation email. We will also be live streaming the webinar on the SERDP and ESTCP YouTube channel at the link shown here. Next slide, please. Today's broadcast will be listen only. You may submit questions by using the Q&A box on your screen. You do not need to wait until the Q&A period to submit your questions. In fact, we encourage you to submit questions in advance of that session. When submitting your questions, please make sure to add your organization name at the end of your question so that we can identify you during the Q&A session. Next slide, please. All right, it's now my pleasure to introduce our four speakers. Dr. Jovan Popovic is an environmental engineer at the Naval Facilities Engineering and Expeditionary Warfare Center in Port Hueneme, California, or EXWC. At EXWC, he has been involved with a variety of environmental restoration projects, covering topics including PFAS treatment technology development, 1,4-dioxane treatment, as well as attenuation of petroleum hydrocarbons, munitions constituents, and PFAS. Jovan completed his PhD at Clemson University, where his primary research focus areas were aligned with the application of electron cycling strategies to enhance wild-type microbial metabolism and discovering novel microbes for the bioremediation and bioprocess industries. Mr. Chris Johnson is a senior development engineer at Pacific Northwest National Laboratory in Richland, Washington, where he has been involved with environmental restoration, remediation, technology research, and development since 1992. He's designed and implemented ex situ and in situ bioremediation systems for treatment of hydrocarbons and chlorinated solvents at US DOE, US DOD, and private industry sites. He is a developer of the Suite software for assessing the impact of remaining Vadose zone source material on groundwater or vapor intrusion. Dr. Katie Muller is a staff scientist also at Pacific Northwest National Laboratory in Richland, Washington. Katie's research focuses on experimental and contaminant fate and transport modeling to understand, predict, and inform subsurface remediation. She earned her PhD from Tufts University in Environmental and Water Resource Engineering and completed her postdoc research in the Environmental Sciences Directorate at Oak Ridge National Laboratory. Mr. David Becker is a geologist with the Environmental and Munitions Center of Expertise of the U.S. Army Corps of Engineers in Omaha, Nebraska. Since 1991, Dave has been involved with providing technical consultation, teaching, review of environmental restoration-related documents, and preparation of guidance relevant to in situ remediation, field studies, and optimization. Dave has participated in or led more than 65 optimization studies of active remedies and monitoring programs for the U.S. Army Corps of Engineers, EPA, Air Force, Department of Energy, NASA, and Navy projects. Dave earned a bachelor's degree in geology from the University of Nebraska at Omaha and a master's degree in geophysics from Southern Methodist University. Jovan, I'm going to turn it over to you now to get us started with today's technical presentation.
All right, thank you very much, Cara. Well, good morning or good afternoon to our folks in the more eastward time zones. So as described previously, today our team is going to be discussing ESTCP project 201731 entitled Development of a Decision Support Tool for Vadose Zone Remediation of Volatile Contaminants. So I came onto this project sort of at its later stages, maybe about a year or so ago, when our team was reaching out to a variety of different installations to better understand the need or applicability of this tool to help rapidly evaluate, for example, the potential for soil vapor extraction system shutdown at each of these respective installations. And now we're at the point of the project where we're wrapping up some manuscript drafts and sort of pursuing some other technology transfer conduits to get this info out to our community. So it's definitely been an exciting undertaking thus far. Next slide, please. To sort of introduce the team here, this project is in collaboration with NAVFAC EXWC. We have Dave Becker and Carl Harms out of Army Corps of Engineers, and we have Chris Johnson, who is going to be speaking on this topic today, as well as Dr. Katie Muller, both out of Pacific Northwest National Lab. So a few of our team members are no longer with us, unfortunately. Both Rob Hinchy and Mike Truex are very recently retired, and Guzel has transitioned to Intera Consultants in Richland, Washington. But we did want to make sure that their contributions to this project will continue to be recognized even beyond the completion of this effort. But in any event, it's really been a pleasure working with such an experienced team, especially Chris, Katie, and Dave, who bring such a wealth of interdisciplinary knowledge and insights to the table here. So now, I'm going to turn the floor over to Chris, where he will be discussing some of the more stimulating elements of the Suite 2 software. Chris?
Hi, Chris. You might have to come off mute.
Unmute. There we go. Are we there yet?
Yes, we're good. Thank you.
Okay. I lost my controls here. All right, so let's go back to the agenda. So today I'll be talking about SEET, and I'm going to start out by talking about soil vapor extraction performance assessment. We'll talk about the project objectives for this project and describe the SEET software, including the interface and the updates that we did. We'll talk about the demonstration of the software, and there's a couple of components for that. And then we'll get into the cost savings and the benefits of using SEET. So soil vapor extraction, I'll just cover that briefly. This is a commonly used technology using a vacuum extraction to extract contaminant vapors from the subsurface in the vadose. Typically is very effective, but it often starts out pulling out lots of mass, and you get diminishing returns over time. So it typically can't remove all mass. So when you're looking at remediating the vadose with SVE, there's some questions that you might ask, depending on what stage you're at in the remedy. When you're first looking at a site, you might ask the question, is SVE needed? You know, does the source in the vadose pose a risk to groundwater or vapor intrusion? As you're proceeding with SVE or designing the system, you might ask, what are the performance goals for this? What mass flux from a contamination source would be acceptable to meet cleanup goals? And then as you continue with SVE and get those diminishing returns, you might ask, when can we terminate this? Can we terminate this? Is the remaining mass a threat to groundwater or soil gas? You might also ask if alternate technologies might address the remaining mass, which really gets to the cost effectiveness of SVE. Is there a better technology that's going to be more cost effective, get the job done sooner, and meet your cleanup objectives? So the Corps of Engineers, PNL, along with the Corps of Engineers and EPA, put together a guidance document about soil vapor extraction to provide a structured approach for performance assessment. And this was really about gathering information to update your conceptual site model. If you've been running your SVE system for a while, you might have additional data that you didn't have back when you did the characterization in RIFS. You want to update the environmental impact pathways and regulatory text if those may have changed. Then you want to quantify some impacts. What are the impacts of the remaining source? And finally, apply a decision logic to determine what is the endpoint for the system. Do you need to optimize it? Can you close the site, etc. So the SVE software tool comes into play in that quantification portion to quantify those impacts. The objectives for this project were to, we had version 1 of SVE that was developed for the Department of Energy, sites like Hanford. And we wanted to, with this project, we want to make sure that we provide a DoD with a widely applicable tool for DoD sites, which meant that we needed to expand the range of inputs that were permissible in the tool and enhance the functionality and usability of the software. All of this, again, is to support the remedial decisions for protection of groundwater and potential vapor intrusion. Another objective of this project is to demonstrate the tool, and we had a couple of aspects for that in terms of verification and usability demonstrations. And all of this is really to provide a basis for potentially significant reduction in cost to complete for remedies. The SVE is the soil vapor extraction end state tool, and SVE 2 is version 2. This is a user-friendly spreadsheet tool. It takes a small number of input parameters to describe a site and estimates contaminant concentrations in groundwater and soil gas that results from a vadose contaminant source. It has a rigorous basis of 5,760 stomped numerical simulations, essentially pre-modeled scenarios that represent contaminant transport under natural conditions, and includes vapor phase diffusion, recharge processes, and mixing into groundwater. So SVE 2 is itself not a numerical model, but it interpolates between these pre-modeled scenarios that we did, these 5,000 some scenarios, and then scales for some of the parameters that have a linear relationship between inputs and outputs. Again, SVE 2 is intended for decision support to help site managers make decisions about vadose remediation that runs this gamut from, do we initiate this remedy? Do we continue? Do we optimize? Are we ready for closure? Or do we need to transition to a different remedy such as M&A or some other active remediation? It provides a defensible estimate of the contaminant transport as a basis for supporting those remedy decisions. So this really fits in that guidance context that I started out talking about. Because we did these pre-modeled scenarios, we had a number of assumptions that applied here, starting with that we assume the vapor phase transport is the dominant transport mechanism for contaminant movement. We do include recharge processes, but it's really assuming the vapor phase dominates. Groundwater is assumed to be initially uncontaminated. We assume that the contaminant source can be represented as a single source area. The subsurface is homogeneous with uniform properties. We're at steady state, have a constant strength vadose source with no source depletion. And for the monitoring well locations, we assume the well screen starts at the water table. A few things are not included in SFEET. That would include adsorption and biological degradation. And again, for the monitoring wells in the groundwater, we're looking at the plume centerline concentrations. We don't look at off centerline concentrations. So taking all those assumptions together, SFEET is generally conservative in that it favors higher concentration estimates. It's not going to, the intent is to not underpredict the estimate and promote closure when that wouldn't be appropriate. So generally conservative, and so it's useful in that decision-making process. We use a generalized conceptual framework for the numerical simulations and for the data input. And so that you see that in the picture here, based on work that we had done previously, we had determined the small number of parameters that we're controlling. And so that's what you're going to enter into SFEET in terms of geometry of how thick is the vadose zone, where is the source located, what's the size of the source, as well as the strength of the source and some of the subsurface properties such as temperature and moisture content, also recharge. And you're going to describe the location for the monitoring well for groundwater or a sub-slab or sub-basement location for soil gas if you're interested in vapor intrusion impacts. This is the SFEET interface. It's very small. We're going to get to a demo later. We'll see this up close. But just in general, we have the section up here in blue, which are the input parameters. And then we have a section in green, which are intermediate calculated parameters. And then finally, the tan indicates the groundwater and soil gas concentration estimates. The color coding is used to describe these different sections, as well as where you have blanks, information that's not necessary, or if there's errors, it shows up in the pink or red color. The tool includes the legend here, as well as helpful information from the user guide to talk about permissible ranges for the inputs. And again, you have the generalized framework here for reference as well. So all that's in the tool, so you have it all together. You don't have to go back to the report. The updates that we did for our SFEETs were based on a survey that we did with a number of DoD sites. We asked about SVE applications, what kind of contaminants and what kind of scenario they had for their site. And then based on that information, we've added a number of new contaminants here. We've expanded the number of scenarios that can be done at one time. Made the locations for the compliance locations that where we estimate concentrations, made that more flexible. Instead of a fixed number of locations, it's anywhere along the center line. We've taken a sister code, sister tool to a SFEET called Vadose, and we've incorporated that into SFEET 2 in terms of providing soil gas output for the vapor intrusion uses. And we've increased the permissible ranges on a number of parameters, including the source concentration, recharge, the residual saturation, vadose zone thickness, relative source position of the source within the vadose zone, the footprint of the source, and the groundwater flow rate. And we've also now allowed the user to specify the porosity and bulk density of the subsurface. We did the demonstration, and it had two elements to it. The first one was to do a ground truthing, where we want to take at least two sites and look at the SFEET estimates compared to observed data and see how those compared. Does SFEET provide some accurate results? So we had a performance metric of being within plus or minus 3 standard deviations from the SEET sensitivity results with that. And then the other element of the demonstration was to do some user testing, where we were looking at sites with SVE operations and the appropriate data, and wanted to get some qualitative feedback on usability and applicability to sites. And the performance metric here was that greater than 80% of sites would be able to use this tool for decision making. I'll go through a couple of examples for the ground truthing portion of the demonstration. McClellan Air Force Base has several sites where they're using SVE. IC1 is one of those that had PCE source material that was impacting groundwater. They had recently terminated SVE, and we had 3 wells that we could look at for our comparison. So what we did was gathered data from the site, and we determined a most likely set of parameters. And that resulted in the blue box on the plots is the most likely estimate from SEET. And we also looked at the minimum and maximum range for each of the parameters and did a Monte Carlo analysis to look at multiple realizations of different combinations of input parameters. And that gives us the sensitivity results here in the box and whisker plot, where you see the median and the different percentiles. And then we have the actual observed field concentration as the X value. And for all these wells, SEET met the performance criteria in terms of matching the observed data. We also looked at the soil gas. So our Corps of Engineers Cold Regions Lab has AOC2 site, which with TCE source in the Vadose zone. And we wanted to look at that impact on soil gas. So we did the same approach in terms of the most likely data inputs and the range for the Monte Carlo analysis. And again, in this case, it met the performance objectives for that site. Overall, SEET provided reasonable concentration estimates in our ground truthing demo. We had 6 cases that matched the observed data and meeting the performance metric. 3 cases were less than the observed data, but they were within a factor of 2 or 3 of the observed data, so not that far off. 4 cases had estimates that were larger than the observed data, which again gives you a conservative result. I'll note that it was challenging to find sites meeting all the SEET assumptions, and I'll distinguish between doing a ground truthing where you're comparing the SEET estimates to observed data and trying to find the match, do those match, versus when you're trying to make decisions about remedies, right? A little different situation in terms of meeting the assumptions. We'll talk some more about that. The other aspect of the usability was the usability and applicability portion of the demonstration, where we found that SEET was applicable to 93% of the sites surveyed out of 14 total sites. 29% of the sites, it was applicable, but we think they probably need some additional characterization to reduce the uncertainty in the input parameters. And of the sites where it was not applicable, there were basically 2 issues. One was that the recharge was too great outside the bounds for SEET, or the site size was either too small or too large, again, outside the bounds of what SEET represents. Feedback from users was good, that SEET was applicable and helpful. They found it user-friendly and had straightforward input requirements, and they could use readily existing data to generate those inputs. They appreciated the fact that it was easy to vary the inputs and quickly run multiple scenarios or what-if analyses, rapidly getting results. It was they saw it as a major benefit versus traditional numerical modeling type approaches, in that it took less labor effort, it was less data intensive, and it was a lower cost to obtain estimated impacts. They also noted that SEET has a similar level of professional judgment and assumptions involved as you might find with traditional numerical modeling approaches. So this was helpful. The rapid analysis was helpful when you're looking at inputs with a high degree of uncertainty, so we could provide insights about the controlling processes and determine where we might need to get additional information to tighten up those estimates. And it did provide useful information for making decisions, remedial decisions. Continuing with the user application demonstration, users had multiple applications that they either tried or considered, saw where SFEET could be useful. There were some users that in the demo that did their own ground truthing. They were folks were looking at the source impacts for endpoint evaluations. They were considering vapor intrusion concerns. They assessed parameter sensitivity and the resulting impacts. And then they were defining things like institutional control needs or performance objectives to meet cleanup goals. So the user conducted ground truthing efforts also found reasonable estimates from SFEET, so corroborating our own demonstration. And the soil concentration estimates were noted as being useful because when SVE closure is proposed, regulatory agencies often ask, well, what about vapor intrusion? So it's nice to have those soil gas estimates as well. So I'll move into some of the benefits here, and the primary benefit being cost savings for DoD. We looked at a DoD site as an example for an application of SFEET, assessing SVE endpoints. And this particular site actually has 8 SVE systems that were assessed. So the outcome of the assessment with SFEET was that 5 locations could terminate soil vapor extraction operations, and 3 locations would need to continue operation. Based on the annual operating costs, we have a little table here that shows annual costs for each of the systems. We flag these as a run or shut down, and that in total was about 663K of savings per year, or about a 62% decrease in operational costs. So we went beyond that one site and got some information more broadly about SVE operational costs that range from 50 to 200K a year, and consider that if we're doing endpoint evaluations for a small percentage of DoD sites with SVE systems, that potential cost savings on the operating costs alone could reach into millions of dollars pretty quickly. Right? With the previous site is 2 years of extra operation would be another over $1 million. So this could add up pretty fast. The other thing we looked at in terms of cost was the labor and application cost. So if you take someone that's unfamiliar with the SFEET software, it would take about 16 hours of labor to run some site-specific scenarios. And that includes installing the software, getting familiar with the software, gathering the data, and performing the analyses and interpretation, with most of that time spent gathering the site data, followed by assessing the scenario variations. So if you take some labor estimates of $80 to $150 an hour, that's $1,300 to $2,400 per site that's evaluated in terms of cost for that analysis. So the key takeaways here are that SFEET is an easy to use tool. It makes use of readily available data. It's broadly applicable to DoD sites and able to represent real field conditions found at DoD sites. It has spreadsheet fast estimates of the impacts on groundwater and soil gas, allowing users to quickly perform those what-if or sensitivity analyses. And it supports a range of remedial evaluations or decision-making processes, including endpoint analysis, remedial performance goals, and assessing potential vapor intrusion concerns. And the software has the potential to save millions of dollars if SVE systems are found that they can be turned off and the site closed. So SFEET 2 has its rapid evaluation capabilities really are something that warrants its use in these performance assessments and optimization studies, with the primary benefit being the potential cost savings. You've got rapid evaluation that provides a defensible analysis for the decision-making that would result in those cost savings. I have some references. The guidance document and some of the other references were mentioned here. The project final report will be published here in February. So you'll find that at the site webpage. And we also have the PNL webpage here. So you can visit either of these pages to get the software. The software that is currently available, it's beta version right at moment, is posted. In February, we'll have the final version. We have a few final touches to add to it for that final version. And that would be all for this portion of the presentation.
Great, thanks, Chris. We will now move into the software demonstration and then the Q&A portion of the presentation. You may ask a question at any time through the Q&A box as a reminder. Chris, you can go ahead and share your screen now for the software demonstration.
Okay. All right, so my screen should be shared and I'm showing the Suite tool. Again, it's an Excel-based tool, so it should be pretty accessible to folks. This is the, what you see initially when it loads. Here's the list of the input parameters by name with symbols and units. And this is the input area over here. So I have multiple scenarios loaded at the moment. You just enter the data like you normally would, and you'll see the intermediate calculations here and then the final estimates down here. If you, you don't have to enter the distance to the compliance well or the information on the location for soil gas. You can choose one or the other. You don't have to have both. Depends on what you're interested in. If you enter a value such as the 0.004 for the groundwater velocity, it's outside the bounds, and so it shows up in red. And so that's the flag to tell you there's something amiss. You're outside the bounds. If you change the value and it goes back inside the bounds, it will then calculate. If it's outside the bounds, it shows up as a value or NA error message in the result. Okay. There's one parameter, the temperature. The software uses Henry's law constant in the calculations, and if you're outside the temperature dependent correlation bounds for that, the temperature shows up in yellow. That doesn't prevent the calculation, but it's just a warning that you're outside that temperature dependent correlation. I will point out, here's another spot where the soil moisture is outside the bounds, so it shows up in the pink red color. I'm going to point out that these few numbers down here, they're kind of small and in gray. They're helper numbers. There's some constraints on the particle density that's assumed between 2.2 and 3 grams per mil. And based on the particle density and the porosity and the bulk density, that is what constrains the soil moisture. So these two numbers here are actually the bounds for that soil moisture value. So I can go up here and enter 12 to be within the bounds, and then the values are calculated. And yes, and this is another example. I guess the other thing I'll point out, you can enter either gas concentrations, if that's what you have, the data you have for your site in terms of what is the source strength, or if you've done some studies and have a mass discharge result, you can enter that as the source strength. You have that choice of those two options. So and as I showed in the screenshot over here, it lists out the permissible ranges for the parameters. You've got the generalized conceptual model here and some notes about the parameter ranges and the parameters, the color codes down here. There is another sheet here that might be of interest. You probably won't visit this too often, but this contains the chemicals and correlation information. So it calculates temperature-dependent vapor pressure and solubility to get the Henry's law constant, has molecular weight, and there's another. Here's the temperature constraints on the solubility, and it also has things like the temperature and density correlations. So all that information is here for reference as well. So that is my quick software demonstration. And I'll turn it back to you, Cara.
Okay, great. Thanks, Chris. We will go ahead now and move into the Q&A portion of this webinar. So thanks for everyone that has submitted your questions already, but please continue as we move forward using the Q&A option on your screen to enter any questions that you might have. All right, our first question, Chris, can SVEET be used to assess the potential benefit of installing additional extraction points, infill, or backing off sections of existing extraction wells, the vertical focus?
So I'm gonna, we'll answer these as a panel. Katie and Dave can jump in. This is not a design tool per se. It's intended to say what would happen if you left the source in place. And so you could play some, do some what if scenarios to say, if I reduced the mass discharge, the source strength, a certain amount, how would that impact the groundwater? Would that be enough? So you can look at some things like that, but it's not necessarily a design tool for SVE. Dave, you have other comments on that?
Sure. Yeah, this is Dave Becker. I don't think SVEET's really going to be able to help you with those specific questions. It has a little bit different purpose, as Chris said.
Okay, great. Next question for the team. Which of the model input parameters are not commonly being measured?
Well, that's a good question. And it was interesting to do our survey of DoD sites where we asked for all this sort of information about those sites. And I think there's certain parameters that the folks don't typically think about. One of those would be definitely the source definition. We had some responses with very large footprints for the source area. And I think one of those was probably a landfill. And they said, well, the area is the entire landfill. So I think that's probably the biggest thing is what, and it's maybe not that they haven't thought about it, but that it's harder to get at would be, where's that source located? How big is it? What is the source strength? So that's probably the biggest one.
All right, great. The next question, do you have any examples of experiences where you've used the model to obtain regulatory approval of transition decisions?
Yes, we do. Dave can chime in here, but I'll talk about Hanford. Again, this was developed for DOE sites. So at Hanford, we have a very thick Vadose zone. It's a semi-arid conditions. And they had disposed of carbon tetrachloride in the soil column over many years. And so soil vapor extraction was used starting in '92 as a remedy and had been running for nearly 20 years. And we did a performance assessment and used the structured approach in the guidance document, where we gathered that additional information on the conceptual site model, the regulatory context, assessed the impacts, and then did our decision logic of where should we go from here. And SVEET was used as part of that. We actually had a treatability study that was done and used STOMP numerical modeling as well. So we had sort of a parallel path that came up with the same results, essentially, in terms of what the impacts were. And so we were able to use that and go to the regulators with these lines of evidence to say, yes, it's time to turn the system off. And if I can explain some more about that depending on what other questions are asked. But Dave, you may have some others that you can talk about as well.
Yeah, sure, Chris. Just to add to that, actually, I think maybe the idea for proposing to do an improved version of SVEET came from the interest on the part of EPA to apply SVEET at a Superfund site in Region 9 to reevaluate the cleanup standards. And so, you know, I consult on that project, and we, at my suggestion, we brought in Chris and Mike Truex, and in conjunction with the responsible parties, we redeveloped cleanup standards specifically using feet. And that's what the project is currently using for decision making right now. So that was a good example. There's another EPA site where SFEET was used to help in providing a line of evidence to actually make a decision to cease soil vapor extraction operation. And I know of at least one other project where SFEET has been presented to the regulators, at least in conjunction with other analysis, to help support developing cleanup standards. So where it's been suggested, in my experience, we really haven't run into a lot of opposition, provided that we make it very clear what the assumptions and you know, basis is for the SFEET tool.
Great, thank you for that. Those were a nice example. Covered a couple questions we had here. This one, Chris, is specifically addressed to you. So how limiting is the assumption of homogeneous and uniform geologic conditions, especially for alluvial settings such as McClellan Air Force Base?
So Katie could answer this as well, but so one of the other assumptions there is that we're looking at steady state conditions. So what would happen if you left a source in place over time? What would the ultimate impact be? And so when you have that steady state assumption, the geology essentially doesn't have an impact. You can have a layered system, or even if you think about adsorption, those are involve transient to the contaminant transport. But if you think about steady states and long term, those considerations go away because you're at the steady states and you've already developed that concentration profile in terms of its impact to transport through the vadose zone and impact on the groundwater or soil gas. So that's an important consideration. And again, finding sites for ground truthing was a little challenging with that. Are they at equilibrium sufficiently where we can do this comparison, right? But if you're thinking about the predictive use and using it for decision making, that's where that it can still be useful. And you can take information on your source strength now and assess what those impacts might be.
Great. Katie, I wanted to give you a chance if you had anything to add.
No, I think Chris covered that one just great. So I'll chime in for later questions though.
Wonderful. Thanks, Katie. All right. In an idealized setting, which system parameters or boundary conditions do you think will have the strongest influence on the results based on sensitivity analyses?
That's a good one for Katie.
So I think, all of the source strength terms are obviously going to play an important role there. Also, we found at one of the sites that actually the recharge was important for kind of helping them determine their model for the site and what made most sense for those ground truthing type efforts. But in terms of the model itself, Chris, maybe you can chime in and with those relationships that we see between the parameters.
Yeah, I don't have a, we do have a table that talks about, as you change a parameter, how does the estimate go up and down? I don't have that right in front of me to share. I think certainly the source strength is going to be a key parameter and have the most impact probably. But you're right, the recharge, soil moisture, these things affect the contaminant transport the most, right? Those are key parameters in terms of magnitude of impact. I guess, the groundwater velocity is another one that can have a significant impact, because if it's very low, right, the mixing into groundwater is much more. You get a higher concentration versus higher velocities. You're going to have lower concentrations as the groundwater moves along. So that's a little mix of answers, but hopefully it gives you a sense. It's about the transport of the contaminant, and then the source strength kind of controls things overall.
Yeah, Chris, do you think that depth to the basically the depth to the bottom of the source relative to the water table, basically the separation between the source and the water table, also is a fairly sensitive parameter if it's not well constrained by site data?
Yeah, and that kind of, it's not source strength in terms of concentration, but it's essentially source strength, and how close is it? What is the transport distance? What's the magnitude of the concentration across that transport distance? So that would be important. So it's really a combination of these factors. I think even the surface, the footprint of the source, right? A larger footprint gives you a chance for more transport to the soil gas location or the groundwater. So that's where our prior work, we worked with Casey Carroll and Mark Brousseau. They had some input on our guidance document and some of the other studies we've done to identify what parameters are important, and that's this set here. So there you go.
Great, thanks. All right, next question. Where there is small quantities of water and you are operating vacuum enhanced recovery, VER, could SVEET help with closure decisions on that approach of effectively an SVE?
Yeah, Dave, I think.
Okay. I'm looking for the question to see it in writing. Could you repeat that again? I just want to make sure that I understand what exactly is being asked about the vacuum enhanced recovery. Because, if the goal of the applied vacuum is really to stimulate recovery of liquids, I'm not sure that there's going to be a lot of applicability there. But can you reread the question?
Sure thing, no problem. Where there are small quantities of water and you are operating vacuum enhanced recovery, could SVEET help with closure decisions on that approach of effectively an SVE?
I guess the thing that pops into my mind in the context of that question is that if you have such a small quantity of water, or the water yield is so low, is groundwater really the mechanism by which exposure is likely to occur, and is groundwater concentration really going to be the parameter that indicates the risk? I suppose that it could be used to, sort of tricked into being used to give you some sense where, maybe the concentrations near the water table, might be considered the source area. I guess bottom line is I think that it would have a possible role in helping you set some standards, but I'm not sure that in most cases it's really going to help you a lot. I don't know, Katie or Chris, do you have an opinion?
Well, I think, I'm not sure if I understand the question entirely. Certainly for if it's essentially a soil vapor extraction application, then I think, yeah, the answer would be yes, it can be helpful. But then there's, as Dave says, depends on exactly what you're doing. I'm not sure we fully understand what that question is.
Okay, that's okay. I think you provided a good answer to it with the amount of water as a reference. All right, so next question. Could you please explain again why the SVE tool has 5 case scenarios and how to use them?
So there's what we did is we looked at these parameters here to say, well, which of these have a nonlinear relationship when you have a source and the estimated concentration in groundwater or soil gas. Which of these are nonlinear in terms of their relationship as you change the parameters, right? And so we identified those, and we identified others that where it was a linear relationship. So the Henry's law, for example, the source strength in terms of concentration, those are linearly related. They just scale. Right? You have a higher source concentration, you have a higher impact to groundwater. So for the ones that there was a nonlinear relationship, we selected some key values to define our range of parameters. And that's what resulted in our 5,000 plus simulations. As you start adding different combinations of parameters, the number of simulations multiplies fast. The version 1 of SVE had 972 simulations, and we've just added we added some additional, let's see, the Vadose thickness. We added 3 more parameters for that. 1 for velocity here. We added another, extended the bounds of in one direction for residual saturation, source thickness ratio, and the relative source position and the footprint. So just adding 1 or 2, a few extra options in terms of what are the permissible ranges for those really ballooned the number of simulations. And so what this does is it does those numerical model simulations and obtains results. So we have along the plume center line, groundwater concentrations, and then the soil gas at 2 depths, a sub slab and sub basement depth, which you see here. You can choose either 1 or 4 meters, depending on that. And so we took all that data from those simulations. It's stored in a data file. So when you install this, you get the Excel file and you get several data files along with it. And then SVE interpolates between those simulations based on your inputs, right? So you're going to put in whatever inputs that describe your site based on the generalized framework that we have. And then SVE will say, well, either that matches exactly, or we're going to interpolate between some simulations to get our estimate of results. So it's there's a lot of simulations, a lot of data to manage.
Yeah, definitely sounds like it. This next question is about the source gas concentration. Specifically, could you provide a further definition of what this is and explain how that would be calculated?
So in terms of the source, what you're looking to do is define the strength of the source. So some sites will have soil gas monitoring locations, and you could use, you have to be selective, look at your data to, as you're describing that source, what is the extent of that source? How thick is it? Where is it located in the Vadose zone relative to groundwater and ground surface, right? And you'd select some soil gas monitoring from that location to represent the strength of the source. The other approach would be to do some mass discharge analysis. So performing things like rebound studies, where you're cleaning out the system, bringing concentrations everywhere down, turn off the system, watch the rebound, and calculate mass discharge from that. So that's the kind of work that we worked with Mark Brousseau and Casey Carroll on. And that's described in the guidance document of what are some approaches to take that to define where the source is and what that strength of the source is.
Wonderful, thank you for that. Next question, how exactly is the Darcy groundwater velocity and permeability related to vapor transport in the model?
So the groundwater Darcy velocity is used in here because we have mixing in the groundwater, right? The numerical simulations include groundwater and Vadose. It's a multi-phase system, gas, water, and oil for the contaminants. And so the Darcy velocity comes into play as there's mass transfer into groundwater and contaminant is carried down gradient. So that's where that's used.
Okay, great. Would it be possible to integrate barometric pumping based on empirical observations?
Good question. I'm not entirely sure how we might do that. I don't know if Dave, if you have any thoughts, or Katie.
Yeah, I would. Yeah, Chris, I guess if I was to weigh in on that, I would say that really the barometric pumping, which I'm an advocate for, but that would disturb the equilibrium that really is one of the underlying assumptions for the analysis here. So I really don't think that SFEET is a tool that would really come into play to help you assess, anything about the efficacy of barometric pumping, or whatever. Certainly barometric pumping could be implemented, and you could look to see after some period of time what the equilibrium source gas concentration would be if you stopped the pumping for a while to see how much progress you made. But otherwise, I really don't think SFEET is going to help you with any kind of analysis of barometric pumping. I hope I understood the question adequately.
I think so. Is there any calibration and validation needed in utilizing this tool?
Pardon, I missed the last part of the question.
Any calibration and validation needing to utilize the tool?
No, so again, this is not a numerical model itself. It's based on the assumptions and the generalized framework. We've used that for the numerical modeling as the basis for this. So what's most important for this is really some understanding your parameters. I think when you have a lot of parameter uncertainty, it's going to be harder to use this to support your remedial decisions. So, there's some moisture content, right? So some of these things are pretty easy to get. Again, I think we go back to the source definition of where is it located, what's the strength of that. That's where you're going to find the most uncertainty. And so I think this might lead you to gather some additional information to better pin down some of the parameters and help with your justification and decision making.
Great. Next question. Does the model address sites with residual Napple in the Vadose zone?
So yes, one of the assumptions is that you don't have a groundwater source. So if you had Napple in the groundwater, that's really a different situation, right? Because you might have the Vadose zone source, but you also have the groundwater source. So that complicates things. But essentially, you could have a Napple in the Vadose zone, or it could be that, you know, at Hanford, the situation was where they disposed an aqueous waste with carbon tetrachloride, and there was a fine grain zone, and carbon tet hung up in that fine grain zone and acted as a source. So either scenario like that would be appropriate. If the Napple were continuing to migrate, you'd have to consider that long term. So it depends on where that's at in the Vadose zone and migration. But definitely should be suitable for that sort of situation.
Okay, wonderful. Next question is, the recharge rates are relatively low. Is this model intended for drier climates and or lower permeability soils?
So I think maybe the confusion here is based on Chris's screen. So it has the average recharge just having 0.5 centimeters per year. So this is just for one specific site. This range, I think, goes up to 15 centimeters per year as the high end, and that's still within the assumptions of those underlying STOMP models. So we can still use SVEET to estimate when we have recharges up to about 15 centimeters per year. So, and then when we were doing the initial survey of various DoD sites, you know, I think it was what, 90-some percent, 80-some percent of the sites fell within the ranges of SVEET. So again, recharge was one that sometimes the sites would go above that upper bound, making it not really applicable. But for the most part, you know, the recharge bounds given in this model update are sufficient for most sites.
Yeah, again, one of the underlying assumptions is that the vapor phase diffusion is dominating here. So if you had a more than 15%, or, you know, based on, again, I showed you some of the limits here, you'd end up having to go to a site-specific model for that. There's a bounds on where you can apply SVEET, and it's pretty broad. It's pretty applicable to DoD sites, but there will be some sites where it's outside those bounds.
This is Dave Becker. I just want to add that just to clarify that recharge rate is a net recharge rate, you know, so that's after evapotranspiration has been taken into account. So.
Great. Thanks for that, Dave, Katie, and Chris. We have another specific question here about the use for California state agencies, and are you aware of SVEET being used or considered for any California state agencies? Specifically asked DTSC or RWQCB.
Yes, and I have had some discussions with someone from California about using this. I haven't gone into a lot of details, but I know they've been looking at using SVEET for these for decision making in terms of closure and endpoints for SPE.
Okay, good. I think it's nice sometimes for people to see how it's been used and out there. So another question about the model. Does the model calculate lateral vapor transport? And if so, without soil permeability data, how is that calculated?
So yes, the STOMP numerical model does, and it does include soil permeability as a factor in there. That's not one of the inputs that we have here. So we've assumed what that is, and you know, the STOMP it's multi-phase numerical model, so it follows all the equations, and I can provide a reference to that too, if folks are interested, more details on the technical basis for STOMP.
Okay.
And actually, I think we do have a GWMR paper in our reference list. That'd be another good resource that describes more of the modeling information.
Great. Next question, how do you determine a single soil gas concentration for a source that has multiple data points?
I would probably, I mean, there's a couple of approaches. And the nice thing about SPEET is you can try different things, right? You could set up multiple scenarios here with different inputs and see what the impacts are. So what we did for Hanford was actually use the maximum concentration, soil gas concentration that was observed. You could do an average. I think maximum would be more conservative, so that's the approach that we took. But you could put that in with the rest of your site description and see, well, what is the impact? You know, if you use the maximum and you're still within your objectives for cleanup, then you'd be good to go. And if it was above, then you have to make some decisions about continued operation or optimization or different remedy.
And I'll just add on that. So for the ground truthing, we ran into this scenario, of course. And so what we did was we used the average in some cases and then used the min and max to get some sort of idea of that sensitivity. So you can kind of approach it that way as well. And the nice thing about this tool is it is Excel based. And so you can change those, do the inputs, and you have near instantaneous results to look at some of those scenarios and the sensitivity surrounding those parameters.
And if I could just kind of weigh in, just kind of on a little bit different twist on that, is that for one of the sites where it's been applied, in my experience, they actually take the average of approximately, I believe it's 8 soil gas sampling points, and compare that to the threshold value that was developed using SPEET. So, you know, that's looking at real site data and comparing it to a standard developed based on the SPEET input. But in that case, just a simple arithmetic average is used.
Great. We have a couple more questions in here. But if anyone else has any, please don't hesitate. Go ahead and enter those in the Q&A box for us and for our presenters. So we have a question here on how the tool can be accessed. I know that it's posted on the project webpage on the SERDP and ESTCP website, and we can enter that link here into the chat box. But do you have any other suggestions for how someone could access that or where to look?
Yes, let me see. Let me grab the link here. It's on our P&L web pages as well. So either of those should be the same thing. Give me a second. I'll put that in the chat as well. So we while I'm looking, we can go to the next question.
Great, I can fill that in here. So our next question, does your tool account for uncertainties of variables, including the uncertainty analyses?
Katie?
So again, we have those different scenario kind of placeholders here that can be utilized for doing some of the sensitivity analysis, but it's not like the Monte Carlo and output of those percentiles. It's not part of the tool. That would have to be done kind of just using the tool and getting those results outside of it.
Okay, great. Thanks, Katie. And thanks, So in your chat box, all the attendees, you'll see the project webpage link from me, Cara, and then Chris has also included the PNNL website where you can access the tool. So you can access the tool through both of those links. And I believe that that's before we conclude, I think that's all the questions that we have. So thank you to the presenters. Chris, if you don't mind, stop sharing your screen and we can pull up the last few slides.
Right, and I'll just say one other thing, if you don't mind.
No.
So I have heard a couple of times. We actually have a seminar next week. If folks want to hear a little bit more about how we've applied SFEET as part of that evaluation process and getting that site closed. Put that link in here as well.
Great, thank you for that. I'm sure people will be very interested. All right, next slide. So before we conclude, I just have a few final items to go through. So our next webinar is on Thursday, January 28th in the Environmental Restoration Program area. This webinar will focus on DoD-funded research efforts to improve screening and treatment approaches for PFAS, and will feature two speakers, Dr. Graham Peasley from the University of Notre Dame and Dr. Linda Lee from Purdue University. Registration is open, so please visit the SERDP and ESTCP webinar webpage to register for this and other future webinars. Next slide. Before we conclude, I want to thank our presenters so much for presenting this webinar today. I thought it was very informative. And I would like to remind all of the attendees that both the audio and a copy of today's presentation will be archived on our webinar webpage in case you would like to refer to them in the future. We would appreciate it if you would please take a moment to complete the survey that will pop up on your screen at this time. This concludes today's webinar. Thank you.